Hello, everyone. Good morning, good afternoon, or good evening, wherever you are tuning in from. My name is Carly, Community Program Manager at Databricks, and I'm very excited to welcome you to this MLflow Community Meetup. Thank you for joining us today. Whether you're a longtime MLflow user or new to MLflow, we're very happy to have you here. All right, before we dive in, here's a quick overview of what's coming up in today's meetup. First, I will talk about how you can get involved in the MLflow community and stay connected. Then we have a technical presentation on recent MLflow Python model improvements led by Serena Ruan, an MLflow maintainer. And finally, we'll wrap up with a short survey where you can share feedback and suggest topics for future meetups. All right, participating in the MLflow community. As many of you know, MLflow is an open source project, and the strength of the community plays a really big role in its success. There are many ways to participate and stay engaged. We have an active community on the MLflow users Slack. And you can also connect with us on LinkedIn for the latest updates. Just go back here. Perfect. MLflow is constantly evolving, and you can be part of that growth. Check out MLflow on GitHub to explore issues, contribute code, or join discussions. Lastly, we host regular meetups, talks, and office hours. To make sure you never miss an event, follow our MLflow event page on Luma. Okay. One of the things that makes MLflow better is feedback from MLflow users. Right now, we're running a short survey to gather input on how MLflow fits into your workflow and what we can improve. Let me just go back to that slide. Sorry about that. I think, Serena, is it advancing on your side?
Yeah, it is. Now it's on the survey page.
Perfect. Awesome. Great. So this survey helps us understand the, I'm just going to, okay. Sorry about that. Okay. This survey helps us understand the biggest challenges you face, prioritize new features, improve the user experience, and stay ahead of emerging trends. The survey only takes a few minutes, and your responses will directly shape MLflow's future. The link to the survey can be found here. I'll drop the link also in the chat wherever you're tuning in from, or you can scan the QR code on the screen to participate. Okay. Now, for the exciting part, let's move on to our presentation. I'm very excited to introduce today's speaker, Serena Ruan, an MLflow maintainer. Serena will be giving us an in-depth look at MLflow Python model improvements. During Serena's presentation, feel free to drop any questions you have in the chat on whatever platform you're tuning in on, whether that is X, YouTube, or LinkedIn. We will address them during the Q&A session at the end. And with that, Serena, the floor is yours.
All right, thanks, Carly, so much. Yeah, let me share my screen. So we are going to start with a presentation. All right. Hi, everyone. I'm Serena from MLflow OSS team. It's super honored to be here to represent some of the latest features in MLflow. And today's topic will be MLflow Python model improvements. Then let's dive in. First, I will walk you through the key stages of developing a machine learning model using MLflow. The first step is, of course, model creation. We start by defining our model, which can be either a traditional ML model or a generative AI model. And DSI has been popular recently. It's an open source project as well. You can take a look. You can use it for authoring Gen AI models. And once we have our model, we need to train it. This involves using different datasets, fine-tuning hyperparameters, and optimizing prompts in the case of Gen AI models. And MLflow helps in tracking experiments, ensuring reproducibility and managing multiple training runs efficiently. Well, after training, we need to evaluate how well our model performs. So we usually use key metrics to assess accuracy, precision, or like similarity in answers for Gen AI models. And MLflow Evaluate can be used here to analyze the results to make sure your model is in good quality. Once we have a well-performing model, the next step is packaging and deployment. MLflow simplifies this process by allowing us to package models in a standardized format for deployment on various platforms. And here is also our main topic today around Python model improvement. Finally, after deployment, we need to continuously monitor the model's performance in production. And MLflow tracing can provide lots of insights here. It was the topic in last meetup. If you're interested, you can look it up on YouTube or on MLflow website. And finally, after monitoring, you probably need to retrain the model if needed, and then we're going back to this loop. So that's basically the key stages of developing models using MLflow. Now let's discuss why MLflow Python model is essential for model management and deployment. So MLflow Python model is a special model class in MLflow that supports customization logic while leveraging MLflow's packaging and deployment capabilities. First is input data format. So when you deploy your model, we need to define the expected input format. And MLflow Python model allows us to specify an input example and also a model signature. This ensures that the model receives data in the correct format, reducing errors from inference. When an incorrect data is passed, MLflow automatically validates it during inference so that we can provide clear and meaningful error messages, helping developers quickly identify and fix issues, since we all know how painful it is to debug based on confusing error messages. And yeah, next reason is it's quite often that your model might need to depend on other artifacts, such as config files or modularized code packages. And code path and load context method inside MLflow Python model can solve this issue for you. It can pack your dependencies and use it when during model inference. And last but not the least, it's super important to ensure a consistent execution environment. So MLflow can automatically infer pip requirements based on the model, and you can also specify your own pip requirements to override the one we inferred, so that we can reproduce the same environment in a standalone place. Okay, and then let's check an example. This example is just I create my model by extending MLflow Python model, and I define the load context method and predict function here. Also, I need to save a config file because I'm going to reuse it inside my inference. And on the right part, I'm just using mlflow.python.log model to log this model. You see, I pass my model instance to the Python model parameter, and then pass a list of string as input example. And for the artifacts, I pass a dictionary that contains the key and the path to my artifacts. And after model logging, we can load it back using mlflow.python.load model and then do inference with .predict function. So first, input example. since we passed a list of string, and it's also saved as part of the model's artifact. You can see the screenshot here. We saved an input example.json file and serialized the input example into it. Also, model signature is inferred based on this input example. So the signature inside ML model file is like this. But remember that for callback, like the column-based model schema, this type represents the type of the column. So here we have string type of input and also string type of output. And then inside predict function, that is where the input data validation happens. We validate your input data against the model signature we just inferred. So for example, if you pass in a list of strings, we will validate it. But if you pass a list of integers, then it will fail. And inside load context method, you can use the config file that we just logged inside the artifacts part, and then define your own way to use it. And also, like, you can check the model's artifacts part. The config.json file is saved together with the model. Also, the last one is the pip requirements. So we auto-inferred it for you, and we generate this requirements.txt file that includes all the dependencies that is needed for your model inference. For example, if you use OpenAI, then OpenAI equals some like specific version will show up in the requirements.txt file. All right. So let's come to the introduction of Python model type hints. During model inference, data is typically just passed directly to the model. However, for MLflow Python predict, the data is first validated to ensure that it matches the required format before being sent to the model. And for those users who are familiar with MLflow, data validation for most of data actually auto-converts data to pandas data frame. That is because our architecture was initially built upon traditional ML models. And for those models, it's super general that they just accept pandas data frame input. But I have to say that this is painful for Gen AI use cases, and Gen AI is super popular recently. So we heard you. We solved this problem starting MLflow 2.20.0. Data validation supports type hints, so that if you provide a type hint during inheriting from a Python model, and then data validation happens against the type hint, so your data is converted just to the format as your type hint specifies. No more pandas data frame conversion, so we solve your issue. All right, so for data validation against type hints, what kind of type hints do we support? We support a list of type hints. Primitive types, of course, and then collection types. It can be either lists or dictionaries, and the fields can be like nested fields can be the supported type hints as well. And union types, so that you can either use union or this format, so that we infer it for you. And optional types, so that this field doesn't always need to be required. And also typing.any, so that it can be any type. But remember, the any type doesn't have any data validation. Well, I have to highlight the Pydantic model type here, because this is super common for Gen AI use cases. Since, for example, LangChain, it has lots of Pydantic-based model type, like chat messages. And by using this Pydantic model as type hint, we can just validate your data against the Pydantic schema for you. And when does the data validation happens? It happens at 2 stages. First one is local testing. If you just inherit MLflow Python model or use a @pyfunc decorator, and no MLflow is involved here, it's pure developing stage, then we also do data validation for you. And the second one is if you lock the model with MLflow. and then you load it back as Python flavor and do inference. The same data validation happens. So this consistency makes sure you can develop your model locally without logging it, and then just make sure to iterate your predict function works well, and then log it with MLflow, nothing changes. Okay, then let's check a simple example around how to use it. So besides inheriting from Python model, it can be as simple as defining a callable here. For example, I just have a predict function, and I specified the model input type hint as list of string. But remember to add this Python decorator here, because that's how we can do the data validation for you. And when you just use this callable, you pass a list of strings, it works. While if you pass a list of integers, it will throw exception. And of course, you can inherit from MLflow Python model. Here is an example of using Pydantic-based model. I define a message class with two fields, row and content, and both of them are string type. And I use list of message as the type hint here in the predict function. And I try to fetch the content field of the message and then connect them as a list. Then when you just create my model instance and use predict function on it, you can either pass a message class, that is a message Pydantic class with row user and content hello, it should work. And also we provide an extra benefit that you can pass a dictionary that conforms to your Pydantic model. So here we just pass dictionary, row user, and content by. So this example also works. And of course, if you pass a list of string that doesn't follow the Pydantic model schema, it will throw exception. So speaking of the benefits of using type hints, first, model signature is automatically inferred based on it. So you don't need to struggle with defining a model signature yourself or worrying about if the model signature can be correctly inferred from input example, because we've seen some issues on GitHub around it's super hard to define model signature. While using type hints, you don't need to worry about it anymore. And second, data validation happens with or without model logging, as we explained before. So this automatic data validation can make sure your data is in good format. And third one is when you log a model, you probably pass an input example, and this input example is also validated against the type hint. So all of these three benefits make sure your data is consistent before and after logging model, and also your input example is consistent with the type hints. All right. But there are some cases you probably don't want to use specific type hints. And that's why we introduce a special type hint called type from example. And this type hint should be used when first you don't want to define a type hint class. Say Pydantic base model is super complex and I don't want to define it. Or second, your input example demonstrates the input format. For example, I have a chat message example, and I always just pass this kind of input example to my data, to my model, and I don't need to fill in extra fields. So this input example can demonstrate everything. And third, you don't want pandas data frame conversion, because that is the default behavior of Python model predict. So if all of those three conditions meets, you can use this special type from example type hint. Let's check an example about how to use it. So here, you just import type from example from mlflow.types.type hints and use it inside your predict function. But make sure input example is a requirement when you use this kind of type hint, because that is what we infer model signature based on. So here I passed an input example of list of strings, And after that, I load the model back as Pythonic. Then this model will be, the model signature will be inferred based on the input example. And there's no data frame conversion. So you can see that Python model.predict list of string is still list of string. So as part of Python model, there's a special feature I want to highlight today that is called models as code. This is not a new feature, but I think some users are not super familiar with it. So if you're using a Gen AI flavors, for example, LangChain, Llama Index, OpenAI, and also your code represents the model. So what does that mean? For example, if you are using Keras model, you need to train your model and get the model weights. So in that case, your code doesn't represent your model because the model includes some model weights. But for Gen AI use cases, your code just represents everything. Say I create a LLM, and every time I create this LLM with a specific model type and those configs, then it's the same as long as the configs are the same. So if these two conditions meet, then you can use this models as code feature to save your model as a Python file and log it. With this feature, we solve the issue about serialization since we saw lots of issues on GitHub about why my LangChain model can't be saved. But you can save it using this feature because we just saved the Python file for you and there's no serialization issue around that. And I will demonstrate this feature later in the demo. So as we mentioned before, last step before deployment, we need to validate your model, of course. And I want to highlight MLflow.models.predict API. It provides several benefits to you. The first one is model dependencies validation. Remember we talked about the PIP requirements during model logging? So this API can validate whether the dependencies logged with your model is enough or correct because it spins up a subprocess and in a virtual environment to load your model and do inference. So it can validate whether the model dependencies are correct and enough. And second one, input data validation. Since we're going to deploy your model, for example, as a RESTful API, then how to query it is a little bit different than direct .predict function. So it could be a string input and there some data conversion happens there. And this API makes sure your input data is validated in that process and it works well after you deploy the model. And the last one is about environment variables validation. For example, you're using OpenAI model. Of course, you need to set the OpenAI API key. And this API provides an extra field to validate whether there are some extra environment variables you need to set after deployment. And still, in the latest release, we did some improvement. Previously, we support local and virtual env as environment manager. And local is actually just validating against your local environment, while virtual env works well, but it's a little bit slow. And now we have UV as env manager as well. It's a super new environment manager, but it speeds up this API more than 10 times. You can check UV's documentation about how to install it, or you can just run pip install UV and it works well as well. And I will demonstrate this in an example here. I'm going to reuse my previous example of Python model. So it's super simple. And I log the model as Pythonic. Then you just call this MLflow.models.predict API and pass the model URI to it. Here the input data is what input data you want to pass to the model. And pip requirements override parameter explains like you can try out different dependencies here. For example, my model doesn't work well with OpenAI 1.0.0, you can try to override it with OpenAI equals 1.0.1 here. And after making sure the dependencies are correct, you can relog the model. Also, for extra environment, AMS parameter, you can pass extra environment, and it can be used to verify whether your model needed or not. And remember to try out UV as M manager here because it's super fast. Okay, then let's get down to the demo part. All right. First, I'm going to start with a simple example that basically collect all my previous examples together as I walk through. So first step, create a model. Here I'm using OpenAI GPT-4o Mini as an example, and the input to this model is a list of message. I just ask it what is MLflow, and it gives me back an answer. So the model is working well. Then I pack it with MLflow Python model. Here I define the Pydantic based model class message and with row and content fields. And inside predict function, I add this type hint, list of message, and the output is string. So I just send this model input to the data, to the model, and then fetch the response content back. Here I create a model, my model instance, and run predict on it, asking what is DSPy, and it can give me back the answer. Here is a showcase about we're really doing data validation, it's not joking. So we pass a list of string, asking what is DSPy, and now it triggers validation error. Going down to the stack trace, you can see we threw an MLflow exception saying that failed to validate data against type hint list of message. And it also tells you which element is incorrect. So this one is incorrect, and we're expecting a dictionary or Pythonic model instance, but you're passing a string. Okay, after validating the model locally, it's time to log in it. We use mlflow.python.log model and pass the model instance as Python model, and also pass an input example. You can tell from the info message here that we're inferring model signature from the type hints. And also we're running predict function to generate output based on the input example so that we can also infer the output schema for you. After logging it and get back the model info, we can check the signature on it. The input is correctly inferred based on the type hint. It is an object with two fields, content and row, and both of them are required string format. And the output is a string format. Next, we load the Python model back. We use mlflow.python.load model and then run predict on it. It just functions well. Also, we are going to validate your model before deployment. Here, mlflow.models.predict API is super useful. You pass the input data, the model URI, and I'm using UV as M manager here. It's super fast. You can see that it resolves packages and installed it. It's super fast. If this API works well, it will give you back the prediction result. If it doesn't, it will throw exception, and you can search on the stack trace to see what's going wrong. Okay, and final step. Here for simplicity, I'm just serving the model locally. You can run this MLflow model serve command to serve the model and sending requests to the invocations URL. Here I'm asking it, is British short hair smart? And it gives me back the content correctly. It says British short hair are intelligent, but yeah, I'm a little bit doubt on that because my cat is not smart. All right, so this is a simple example about how the workflow goes. And next, I'm going to dive into a little bit complex part to demonstrate how to use MLflow features, including the topics we talked about in last meetup, that is around Unity catalog, tools, and tracing. And also MLflow tracing is integrated with Jupyter Notebook, so I'm using Jupyter Notebook to demonstrate here. First, I turn on MLflow.LangChain.autolog so that tracing is automatically on. Inside create model creation, first step is creating a tools. I'm using Databricks Unity Catalog for simplicity here, but you can also use the OSS version of it. It's also simple to set. Here, I just create a Databricks function client and set it as the default UC function client. And set my catalog and schema. There are two functions I'm going to use in this demo. First one is executing Python code. So I define a callable here. If you pass a string of code, it will execute it and return the value as string. But remember to include the explanation of what this function does in the docstring, and also the code, like what the input parameter means, so that the agent can understand it super well afterwards. And then I use this create Python function API in the client to create it. And besides creating function based on a Python callable, you can also directly define your SQL to create it. And here I'm using a SQL function to create. Databricks has this advance of using AI functions, so I'm just using it here. It's super simple. You follow this SQL grammar to create or replace function and add comment to the field to the parameters. Here, content means content to translate, and language, of course, the target language. And then call create function on this SQL body. It just works well. It returns back a super long function info, but it doesn't matter. Okay, and then I'm going to use the Unity Catalog LangChain package to generate your LangChain compatible tools. Here I'm using UC function toolkit, and it's super simple. You just pass the function names we generated previously as the function names here, and tools can be fetched using toolkit.tools. You can take a look at the tools here. It's a list of Unity Catalog tool with name, description, and the parameter schema. Okay, after defining the tools, it's time to define a model. Here I'm using a LangGraph model. It's from the quick start of their website. I defined the tool node using the tools I defined before, and the main model here is Chat OpenAI still using GPT-4o mini. Then you define the graph. Here is a state graph. You can add node to it, add agent node, add tools node, and add edge. Yeah, I'm not going to dive deeper into it because it's a quick start from LangGraph. And after everything, we compile the workflow and generate the model. First step is, of course, testing the model locally first. Here, we're passing messages, asking him what is MLflow, keep the response concise and reply in Chinese, and fetch the response. Here, MLflow tracing comes. You can see the process of how this agent is working, and inside each step, what is the input output, what is the attributes, and if there's an exception happens, you will see a red icon near this events tab telling you about the stack trace. So here you can see it's using this tools from my Unity catalog, and the whole step is super clear. So MLflow tracing is helping so much about debugging here. Okay, and then now I'm going to explain the models as code feature. Since we have defined this whole bunch of tools model, I'm going to put them into a Python file. Like the agent.py file here, it's basically just putting everything together, define your model as app. And I'm demonstrating the type hints here as well. So I define a Pydantic model of message still, and then we can reuse this Pydantic model nestedly. So here I'm defining messages field as list of message, and this is my model input. Then I inherit from the Python model and use list of model input as the type hint in the predict function. And inside the predict function, I just define how to invoke the model based on my input. And then I create my model instance. And this step is super important because that is required in MLflow so that we can know which model inside this file is really the model you want to log. So we call this set model API on the instance I just created. And that's it. That's the agent.py file. So how do we log it? It's still similar. We still call mlflow.python.log model, and we pass the path to the saved model file as Python model. Remember before we just passed a model instance, and here we can pass the model file name directly. And also you still need to pass the input example to validate the model works well. And that's it. After it's logged correctly, you can load it back as Python flavor and then do predict on it. Here you can see that it gives back the response correctly, and still MLflow tracing shows you the steps it takes. Here it just asks chat OpenAI the question and it gives you the response. And final step here is to validate it before deployment. We still use MLflow.models.predict API and pass UV as the env manager. It resolves the dependencies and finally gives you the prediction output. So this is a little bit more complex demo, but it demonstrates how to use MLflow features together with MLflow tracing and Unity Catalog tools. All right, I think that's all for my presentation. So, Carly, I think we're good to take Q&A part.
Awesome. That was great, Serena. Thank you so much. We do have some questions here. So the first one that came in, how does MLflow handle complex or nested data structures as type hints?
Okay, so could you pop up the question on the screen as well? Just so that I'm going to answer it. MLflow type hints, so complex and nested data structure can of course be presented as Pydantic based model, and that is a super important case. Just as the model input I demonstrated before, inside the model input we have messages field that can be list of message, and that message can be another Pydantic based model. So in that case, you can just define whatever data structure inside the Pydantic model and use it nestedly. But of course, if you just want, for example, list of dictionaries and you don't care what field it is in the dictionary, you can also specify list of dictionary, string and string as the key value or another type of the value type. So MLflow handles it correctly just using Pydantic based model.
Excellent. Going off of that, what is easier to use for complex input structures, type hints or a Pydantic model?
Okay, for this question, I think you already got the answer. So you can use Pydantic model as the typing directly. Yeah, that's it. It's super simple.
Perfect. Here's another one. Do you have a recommended workflow for transitioning existing MLflow models to use the type hint validation system?
Yeah, of course. I think that depends on which flavor you are taking. Are you using MLflow embedded flavors, or you are using MLflow Python model already? If you are using MLflow Python model already, what you need to do is just add type hint to your predict function and upgrade MLflow. It will automatically work. And if you are using MLflow embedded flavors, I think we currently don't support type hint on that because the predict function is implemented by MLflow. And I think in that case, you don't need to worry about the type hint validation as well because we validate your input already. So I would say if you're using MLflow Python model, just upgrade MLflow and try it out.
Perfect. Another question here we have from the audience. How do you properly version models that use type hints if the input schema evolves over time?
Okay, for this one, I think that's speaking of how MLflow works. So type hint exists in the predict function. If you are going to record every version of your type hint, then that means you need to log your model every time your type hint changes. Speaking of that, you can just use mlflow.python.log model to log your model. And if you are going to register a model, that's how model version works. Because model version persists and it also links to the logged model artifacts. So I would recommend if you want to preserve the version, you can use mlflow.register model to register the model and specify different type hint in the predict function.
Great. Perfect. Thank you so much. We have another question. How does the type hint system integrate with MLflow's model registry and versioning?
Yeah, so the type hint is actually part of the Python model. MLflow model registry still works as it's supposed to be because MLflow model registry records your model version, and you can log as many as model possible, but only when you pass the register model name, that's when we register the model and save versions. And the type hint is saved as part of the model artifacts. So it's actually the same as the saved model artifacts. So yeah, I think this question is a little bit similar to the previous one, but you can still change your type hint in the predict function and register your model again so that it can be preserved together with the MLflow artifacts.
Excellent. Another question we have. Was this change also part of minimizing regression risks and modification of that scary section of the code base?
Yeah, that's a good question. Because MLflow is built upon traditional ML models, and we have this convention of converting everything to pandas data frame. But we also want to support Gen AI flavors for simplicity because you don't need pandas at all for using LangChain or OpenAI. So here we're just introducing type hint, so we don't need to touch any existing traditional ML flavors, but still supporting users who want the data to be passed as it is. Yeah, that is exactly what we want to do here.
Great. And another question that came in, thanks Mohammed on YouTube for submitting this. This is my first interaction with an ML model. Can you briefly explain how this tool is helpful in data and intelligence world?
Okay, so for this question, it's a general question. I'm going to. Can you show the first slide of my deck around model the workflow of model creation? Okay, let's see here. I think this slide shows how MLflow works in the data and intelligence work, right? So from model training to model evaluation, all the way to monitoring, MLflow has tools to support you in every step. Inside model training, MLflow experiment tracking is super important to create runs for you to record the parameters you are using in each training cycle. And also model evaluation just keeps track of your metrics so that you can train your model over and over, but remember which one is the best. And model packaging, it's important because if your model is going to go production, you have to pack it and serve it. And MLflow tracing helps you monitor your model in production. I have to say that in data and intelligence world, monitoring is super important, and that's also why we mentioned MLflow tracing in last meetup as well. MLflow tracing helps you traces all your data, and that data can be used to reevaluate your model, see how your model is performing. So basically in every step, MLflow touches. And if you have any features that you want MLflow to build on, please feel free to file an issue on GitHub. And yeah, another piece that I want to highlight here is even at the model creation stage, there's a super popular framework here called DSPy, so that it's a new agent authoring framework that you can use. So this is the cycle. I think MLflow helps in every step when you're building a model.
Awesome. Actually, the most asked question here is, will the notebooks be made available?
Oh yeah, of course. Yeah, I will share it with you later.
Fabulous. Awesome. So audience members, look out for that. We will be sure to share the notebooks with you. Okay, just double checking here if there are any final questions. Okay, I think that's all of them, Serena.
Okay, that's awesome. Thanks everyone for asking questions. And if you still have follow-up questions, feel free to file an issue on GitHub.
Awesome. And keep in mind, join the MLflow user Slack. Continue the conversation there. It's a great place to ask questions and meet other fellow MLflow contributors.
Yes, and our team will also continue to start to answering questions in that channel actively as well.
Great. Actually, Serena, would you advance to slide 20 on your deck, please?
Oh, okay.
This is actually the final slide of today's meetup.
Yeah.
Let's see here.
Here it is.
Perfect. Great. Thank you so much, Serena. That was a fabulous presentation, and thank you all for joining us for this MLflow meetup. Before we officially wrap up today, we want to hear from you. We're always looking for topic suggestions for future meetups. If there's something that you'd like to learn about, please let us know. Scan the QR code on this slide. We want to hear your feedback and any ideas. And with that, we are done for today. Thanks again for being part of the MLflow community, and we will see you at the next meetup. Have a great rest of your day, everyone. Thank you.
Thank you.